The next one is quite similar to other questions we've had, so I might combine it with the final question. So briefly, could you just detail how Robotaxi will roll out? Will it start with a Tesla deployed fleet and then allow customers to add theirs on like a subscription model? And then will Hardware 3 be capable of level 5 FSD?
Regarding the Hardware 3, what we saw with 12.5 was it was easier to make rapid progress with starting with Hardware 4 and figuring out the solution and then backporting it to Hardware 3 instead of directly working on Hardware 3, given that Hardware 4 has more like fundamental hardware capabilities. I think that trend will continue into the next few quarters as well, where we first figure out the solution rapidly with AI4 and then backport it, write the kernels. It just takes longer to develop those things because it's not fundamentally supported in the hardware and it's emulated. But yeah, it's working on Hardware 4, backporting it to Hardware 3.
Yeah, so it's, I guess the answer is we're not, but our as a short mentioned, because by some measures, Hardware 4 has really several times the capability of Hardware 3. It's easier to get things to work with Hardware 4, and then it takes a lot of effort to sort of squeeze that functionality into Hardware 3. There is some chance that Hardware 3 does not achieve the safety level that allows for unsupervised FSD. There is some chance of that, and if that turns out to be the case, we will upgrade those who bought Hardware 3 FSD for free. And we have designed the system to be upgradable. So, and it's really more, just to switch out the computer type of thing. Like the cameras are, they're capable. But anyway, we don't actually know the answer to that. But if it does turn out, we'll make sure we take care of those who bought FSD on Hardware 3.
Great. In the last few minutes that we have left, we will try to get in some analyst questions. The first question will be coming from Pierre Farragut at New Street. Pierre, please feel free to unmute yourself.
Thanks a lot, guys, for taking my question. I was wondering about the compute you're ramping up. So you gave interesting statistics on how much you have, and you said you don't feel you're compute constrained. And I was wondering, how you are putting to work this additional compute. Is that a game for you of creating larger and larger models, like next generation of models that are larger, the way OpenAI go from GPT-3 to GPT-4? Or is that more like you're set on your model and you need to throw more and more compute to accelerate the pace of learning to improve reliability? And then I had a quick follow-up, real quick, on your rollout in Texas and in California next year. The plan, as you see it today, is it to roll out a fleet or two with cars that will start with a supervisory, some onboard supervision, someone sitting at the wheel just in case, and removing the supervisors progressively? Or are you aiming for going full-fledged without even a human supervisor when you get started?
Okay, well, I guess we're going to. I'll answer the first part of the question. The nature of real-world AI is different from, say, an LLM, in that you have a massive amount of context. So that you've got case of Tesla 7 or 8 cameras. That 9 up to 9 if you include the internal camera. So you've got gigabytes of context, and that is then distilled down into a small number of control outputs. Whereas it's like you don't really. It's very rare to have. In fact, I'm not sure any LLM out there can do gigabytes of context. And then you've got to then process that in the car with a very small amount of compute power. So it's all doable and it's happening, but it is a different problem than what, say, a Gemini or an OpenAI is doing. Now, part of the way you can make up for the fact that the inference computer is quite small is by spending a lot of effort on training. And just like a human, like you, the more you train on something, the less mental workload it takes when you try to when you do it. Like when the first time, like a human starts driving, it absorbs your whole mind. But then, as you train more and more on driving, get very good, then the driving becomes a background task. It only absorbs a small amount of your mental capacity because you have a lot of training. So we can make up for the fact that the inference computer is it's tiny compared to a 10 kilowatt bank of GPUs, because you've got a few hundred watts of inference compute. We can make up that with heavy training. So yeah, that's and then there's also vast amounts. The actual petabytes of data coming in are tremendous, and then sorting out what training is important was, of the vast amounts of video training, or video data coming in complete, what is actually most important for training? That's also quite difficult. But as I said, we're not currently training compute constraint. I'm sure if you want to elaborate.
Yeah. Like you mentioned, the training helps both train larger models, also to train quicker. But in the end, we still got to pick which models are performing better. So the validation effort to picking the models, because the miles per intervention is pretty large, we have to drive a lot of miles to know in closed loop. We do have simulation and other ways to get those metrics. Those do help, but in the end, that's a big bottleneck. Yeah, that's why we're not training compute constraint alone. And there's other axis of scaling as well, which is the data, figuring out which data is more useful. That is an important task, and we're focusing on that.
Yeah.
So as it relates to the second part of your question, Pierre, about safety drivers and rolling it out, each state has different requirements that, in terms of how many miles and how much time you need to have a safety driver and not have a safety driver. We're going to follow all those. We're not going to violate whatever regulations are out there, but safety is a priority.